Hi all, and on the screen today I want to talk about data types and the data type conversion. I know I harp on data types a lot because it is important, and as we go into CCW, and even if you ever have to do Siemens, data types become something that you have to know, but you also have to know how to handle data types, because as I said once before, in CCW, instructions are basically or they basically cannot have mixed data types. So in front of on the screen here, I have a list of data types that come from the IEC 61131-3 standard website, and some of these data types we've talked about. We've talked about the bool and the cint, and we've talked about int and dint, and we also talked about real. There's just a few on here that I want to mention to you that you probably have not seen in the Studio 5000, such as ucint. The ucint is an unsigned short integer, and take notice it's 0 to 255. So there's no negative numbers. Exactly what it says. It's unsigned. So this is an 8-bit word, which is 2 to the 8th minus 1, which is 255. You'll also take notice that the next one down is called a byte, which is a single byte mask. It's a little confusing the way this is designated, and they show the range in hexadecimal. This range, however, is 8 bits. It's very similar to the unsigned integer type. Now, the difference is the fact that the cint type and the int type and the dint type, these are all based on the size of this is based on the processor. So that means that in some processors you may have an int that is, instead of 16 bits, it may be 32 bits. So you need to understand your processor. Now in the PLC world, we know that our processors are 32-bit. So an int would be 16 bits. A cint would be 8 bits. In the computer world, though, which are 64-bit machines, a dint would then be 64 bits, and int would then be 32 bits. So again, the cint, the int, the dint, these are all based on the processor. The byte and the word and the D word are fixed at 8 bits and 16 bits and 32 bits. So that you always know that that's what they are no matter what processor you have. Also, that data type is used mostly, and I'm talking about the unsigned and the byte and the D word, they're mostly used when you're doing logical type work, such as ands and ors and exclusive ors, that type of thing. The int, the cint, the dint, they're used for mathematics. So we have to be aware of the data types. That's my whole thing here. I want you to be aware of the different data types, because you're going to see in this demonstration where the data types make a difference in how you do things in CCW. So let me switch over to CCW. And I created a new project already. And I renamed it data types just so I know that's what it is. And I created a ladder routine called data conversion. There are data conversion instructions in CCW that can be used when data types do not match. Let me do an example of from last semester when we did our math lab. If you remember, and if you don't, you can go back and look at that one lab that we did. Let me bring in an instruction, and I'm going to make this an add instruction. And let me create this. I'm going to reproduce what we did in that lab. So we had, in our first example, we were adding ints. So let me create a couple of tags here, and I'm going to call this tag source A int, and I'm going to make it an int. And I'm only calling it that so that I know by looking at it what data type it is. And when you hover your mouse on it, you can see that it's type int. Let me create another one here called source B int. And let me create a destination of type int. So we'll do a destination of type int. So now I have an add instruction that is of data type int. And if you remember, what we did was I had another add instruction. Let me put this add instruction in. And we used the destination of the first add as one of the sources for the second add. So let me just add this destination. All I'm going to do is type D to bring up the D's. Destination int. And now I'm going to create, because this one I want to be dint. Also, when you hover your mouse over the instruction, again, we get a pop-up, and it says that the I1 and I2 can be any data type. That's a little misleading in the fact that, yes, they can be any data type, but they have to match. So this is an int. I'm now going to come in here and I'm going to create a source B dint. Now I have a dint tag. And I'm going to create a dint for the destination. Okay. Let me just add a way to execute this instruction. And I'll just make it internal. All right, so there's a somewhat duplication of what we did last semester. So I've got two ints to an int, and I've got an int, a dint, and a dint. Now, instead of trying to download this, I'm just going to do a build, and that's this button right here. So this will build it, and it'll check for errors. And it tells me that I do have some errors. Destination dint, it was expecting an int. Source B dint, it was expecting an int. All right, so it's expecting that because the source A input on that is int. You can double click on any one of these and it'll take you to the point in the program code where that error exists. Okay, so since I want this to be doing dints, I don't want to change these to ints because maybe the data coming off of those, I require a dint. So what I need to do is I need to make a little bit of, I need to add something here. And what I need to add is a conversion instruction, and I'm going to convert this int to a dint. Now I'm going to have to do that before I need it. So I'm going to come up here and I'm going to add a rung. I'm going to put a block instruction on it. And if I scroll through this list, you'll see a whole list of any to bool, any to byte, any to, these are all data conversion instructions. So I need to convert an int to a dint. So I need an any to dint. So I'll double click on that and it puts an any to dint. Now my source on this is going to be, or my input 1 on this is going to be this int. So I need destination int. So destination int. And my output now has to be a different tag. So let me do a, I'll just call this converted or convert int. Convert int to dint. And it is a dint type. It's set to a dint type because it already read the instruction so that it knows that it should be a dint. So let me say OK. All right, then I have to change this tag to this tag. So let me click in there and delete that. And then I'll type a C and do that. All right, so now I have 2 dints in, 1 dint out, 2 ints in, 1 int out, and I'm doing the conversion before I need the tag data. So now if I do a build, it should pass. And it does. It succeeded. So it's necessary for us to keep track and know what data type we need, what data type we want. Because and it's important that I'm sorry, it's morning here. I'm a little sleepy yet. But it's also important when we get some instructions that require certain data types as their inputs or outputs, but yet the data we have for our input is not the same data type. So, you know, you can't just connect that stuff. You have to do the conversions. Let me do one more thing. I'm going to try to keep this video as short as possible. So let me add another rung. And I'll just put it on top. It doesn't matter for what I'm doing. And what I'm going to do is I'm going to put a timer in here. And I'm actually going to use a tag or a variable for my preset this time. So let me create a tag for this. And I'm going to create this as a timer PT. I want you to notice that the data type came up as time. And that's correct because the preset value of a timer has a data type of time. So let's do an OK. And I'm also going to this time add a variable for the elapsed time. So let me do this. And I'm going to say timer ET. It is also data type time. So we'll do an OK. Let me put an instruction in here so that, let's see, start timer. All right. Okay, that's all I should need there. All right, now I'm going to add another rung, and let's say that I would like to compare the value of the elapsed time, the accumulator of that timer, to the value of another tag or to a program constant. So I'm going to use a comparison instruction, and we haven't done those yet. And I don't want to cover comparisons because they're so easy. But let me bring it. It's a block instruction. I'll bring a block instruction in, And let's say that we're going to compare that it's less than. So I'll find the less than instruction. I just double clicked. And I want to compare the timer extended time, the ET, the accumulator, to the value of another variable. So I have two ways that I can reference this ET. I can either reference it with the timer ET variable, or I can use the dot notation. So I'm going to use the tag. So click in here, type a T, let's see, timer ET. Okay, there we go. And I want to compare that to the value of another tag. But this tag happens to be a dint. So I'm going to double click here and I'm going to say less than I2, and I'm going to make it a dint. And then my output could be just a coil or another instruction. So now I have a data type here of time, as you can see, and I have a data type here of dint. Well, guess what's going to happen? When I do a build on this, it gives me an error. And it tells me that less than L2 is expecting a time. Let me go to that part of the ladder. It's expecting this to be a time database or a time data type because this is time. Now I can do one of two things. I can either convert this time to dint, or I can convert this dint to time. It really makes no difference. Let's convert this ET to dint. Again, I have to do it before I use it. So let me bring a rung in, bring a block in. And by the way, these conversions don't have to be on a rung by themselves. They can be on the same rung that you're doing the conversion for, as long as the conversion occurs before you need that value out of its output. All right, so I said I was going to convert this to dint. So any to dint. Where are you? There you are. And I want to take my timer ET. But you know, instead of using the tag this time, I'm going to come in and say ton1.et. Same reference, just accessing it differently. And then I'm going to delete the timer ET. And what I'm going to do is I want to use that timer ET tag for the output of this and the input of this. So let me go back to, well, I thought I had it open, the local variables. And I'm going to find that timer ET, and I'm going to change this database or this data type to dint. So I did that. And then down here, I'm going to say I want this to go to timer ET, and I want this to go to timer ET. Now I have a dint and a dint and a dint and a time, and this should now work. So let me build this. Uh-oh. What did I miss? Timer ET expecting time. Timer ET expecting... see, I missed that. I said, I'm going to just change that data type. But this has to be of type time. So, let me go back and make this type time. And that means I have to create another tag. So let me say timer ET dint. So I just created it while I'm there. This now should be okay. Timer ET dint, timer ET dint. So this is now time, dint. All right, let's see if it works now. Oh, I'm still getting an error. I'm getting an error now because, oh boy, because this is now the wrong data type. So you can see, you could get yourself into a loop here if you're not paying attention to what data types belong together. So this is now time, this is now dint, so I've got to fix one of those. Let's see, this is the time, this should be time less than I2, less than I2. All right, so let's do this one to time. So let's see. Actually, if I just use the timer dint ET dint tag, I can do that. Timer ET dint. And let's double check that. Okay, and now I've got success. I just forgot to change that tag. So you can see that you need to really pay attention to the data types that you're using and the data types that an instruction requires. And you have to make sure they all match. One last thing and I'm going to let you go. And that is, I used a variable for this preset. If I download this program to the processor at this time, that preset won't have a value in it. So I can preload that preset. So let me go to the variable monitor, and if I go to timer PT, that's the tag, I can come across here, and where it says initial value or project value, I can type in a value for that timer PT. It's a data type time, and because it's a data type time, I need the format t hash, and I'm just going to make it 5 seconds. Okay, so I've set the initial value for that. So this should be 5 seconds. So let me start the simulator. Turn that little puppy on. Okay, and let me download this. All right. And you'll see that it was initialized to 5 seconds. So that when I turn this on, that timer will time for 5 seconds. I also want you to see that even though I'm entering t hash 5 seconds or t hash with some time, in dint mode, it's just like in Studio 5000, it's in milliseconds. So 5 seconds would be 5,000 milliseconds. All right, guys, I'm going to let you go. This video is really extra crude. I probably should have waited till later, but I want to get this stuff out there because the when I start doing the HMI stuff, they're going to be a little bit longer because there's a lot of steps. Hey, hope everybody's well. Take care, and I'll see you in the next video and online.